Very good morning, my friends. In today's video, we are going to work out a problem on the sections of a square pyramid which is cut by a section plane which is normal to VP and inclined to HP such that the true shape of this section is a trapezium of the given side. Friends, and he has given in the question that this is having a side of 40 mm and the size of the true shape of the section, that is the parallel sides measuring 30 and 20 is given, and is specified that one of the base edges is normal to VP. So there are four edges of the base: AB, BC, CD and DA, and one of them is perpendicular to VP. So we will place the object on HP such that one of the edges is normal to VP and obtain the top and front views of the square pyramid. In the top, it is going to be seen as a square with all the diagonals joined meeting at point O. So let me mark down the top view of the solid. So I will write down the solid to the given dimension. So it is a square having dimensions 30 mm, 40 mm by 40 mm. So I will call this as 40 SQ. So SQ indicates it is a square. And we will label this as A, B, C, D. So this figure represents the base of the solids. We will join these diagonals AC and BD, and this meet at O, which is the vertex of the solid. So this is how a square pyramid is seen when it is placed on HP on its base. So OA, OB, OC and OD represent the top views of the four slant edges OA, OB, OC and OD. Friends, let us obtain the corresponding front view for this square pyramid. So project lines from there, and here you are going to get the points A dash, B dash. This is going to be C dash, D dash. This line A dash, B dash, C dash, D dash represents the base of the solid in the front view. Let us obtain O1, the center of the base. So O1 I will mark here. Through O1, draw a vertical line, show the axis and mark this O dash, the front view of the vertex, and join this O dash to the corners AB and CD. Friends, the height of this solid is given to be 65. So I am going to mark 65. The length of the axis or height of the solid is 65. Friends, we have the front and top views of the solid to the given orientation. Now friends, it says it is being cut by a section plane such that the true shape you get is going to have a trapezium and with these dimensions 30 mm and 20 mm. Friends, when the true shape of the object is given, you can obtain the section plane and its orientation with HP, and when the orientation is given, you can obtain what is the true shape of the section. Friends, here he says it should have 30 by 20. So suppose say it is cutting like section plane is normal to VP. So here it has to cut two slant edges OA and OB, and the dimension should be equal to 30. And since it is inclined here, the cutting point will be somewhere here, little above this, so that the dimension here will become 20. So what I do to get the section plane's position, I'm going to write a horizontal line through this, and on that I just mark the longer side is 30 mm. So I will mark 15 millimeter on either side. So 15, 15. So 15 millimeter I will mark here, and again 15 millimeter here, so that this side while projected, when projected, will give you a length equal to 30 mm. That is 15 plus 15, 30. So the longer side of the trapezium will be 30 millimeter. Similarly, on the other side, friend, I will take 10 millimeter, 10 millimeter, because the total side should be 20. So I will take 10 mm above this horizontal, 10 below. So this will be the dimension 20. So they meet somewhere here, friends. So these are the 4 points where the section plane is cutting the solid. So friends, we will call these points as 1, this is 2, this point is 3, and this is 4. So we have got all the 4 slant edges being cut by the section plane, which is normal to VP. So how to get the corresponding point here? Friends, when you have the object section plane here, you can get the points. Now you have the points, you can obtain the points where the section plane is cutting the slant edges. So from this point 1 and 2, I am going to write a vertical. So this vertical will cut OA and OB at this point. So this is point 1 and 2. I will mark it as 1 comma 2. Likewise, 3 and 4 are here. I will just write a vertical line from there. Vertical line from these two, and here you are going to have 2 more points, 3 and 4 on that. Somewhere above this it will be cutting, because it is only lesser dimension. It should be something like this. So you will get point 3 comma 4. Friends, we have 4 points on the section plane where it is cutting the solid. So I will just join these by a straight line, and I extend this. So I have got the points 1, 2, 3, 4. After getting those points 1, 2, 3, 4 on the slant edges in the front view, I join them and I get the position of the section plane. This section plane SS is perpendicular to VP and it is at an angle. This angle theta is to be found out. Is asking you also measure theta. Friends, we have got the front view of the solid, and that front view which is retained is the lower part that I am going to show in dark lines, and after this is cut, this portion is thrown away. This figure will give you the front view of the solid FV, and here you have got 1, 2, 3, 4 points. We are going to join them by straight line, and here we are going to hatch it. This will also be trapezoidal in shape. The full object here, along with this, will give you the sectional top view, which I represent as STV. The sectional top view of the object, we have the front view. So I got sectional top view, I got the front view, and true shape of the section. Already the dimensions are given to us. I should get the true shape. What is the procedure to get the true shape? We should write a line parallel to that section plane anywhere above that outside the object. Suppose say this is a line that is drawn parallel to SS. After getting that line parallel to that at any convenient distance from the object. So let us see how to obtain the true shape. Already is given as trapezium. So from 1 and 2, from this point and from this point, we will draw lines perpendicular to this. So this line I have drawn is perpendicular to that. Similarly from here, I will draw another line perpendicular. So these two lines are perpendicular. And section plane line and this line x1, y1, they are parallel to each other. So I should get 2 points on this line, 2 points on this line, totally 4 points. The 4 points on the trapezium. How to get them, friends? Suppose I want to mark 1 and 2. I should take one distance from here. So this distance 1 from xy is to be marked here. Similarly from here to here, the two distance is to be marked on the same. So I am going to mark 2 here. 1, 2. Similarly friends, we are going to mark the other two. That is 4 is nearer here, this much on this, and then 3 away from there. So we are going to get 1, 2, 3 and 4. So I got all the 4 points of the trapezium. Join them by straight line. So 1 to 2 have joined this also. So this is to be joined here. I am going to join 2 to 3. Friends, I got this figure a trapezium, and I am going to section it or hatch it by writing lines parallel at an angle of 45 degrees to the horizontal. Friends, this figure will represent the trapezium, which is the true shape of section that is obtained by cutting this solid at an angle theta. The angle theta can be measured using a protractor. And friend, one important thing here is, if you have this distance, if you measure this distance, very obviously it has to be 30. So this is 30 mm. One of the side, the longer side of the trapezium, and other side, on the other side, it is going to have dimension 20. So this is 20 and 10 plus 10 is 20. So friends, in this problem, the dimensions of the trapezium, the true shape of the section obtained in the section plane is at an angle theta to the horizontal. And we have got for this specification the sectional top view, the front view, and then the true shape of the section, which is a trapezium having parallel sides measuring 30 mm and 20 mm respectively. And this dimension depends on the orientation of the section plane. Friends, I hope you are convinced with the presentation I have made, and if you are happy with the presentation, do subscribe to my channel. Share the information with all your friends and have a wonderful day.